Welcome to Planetterrian Daily, episode 116. Today is July 10th, 2026. Let's get into today's research and health developments. Modified low-protein Mediterranean diet helped mice eat more while losing fat and reducing frailty. Researchers tested a low-protein version of the diet that retained enough methionine on laboratory mice. The animals consumed more calories yet showed lower body fat, reduced frailty, and extended health span compared with controls. Human observational data in the same report linked lower animal protein intake to reduced obesity and type 2 diabetes rates. The mechanism appears tied to altered amino acid signaling that favors fat oxidation without restricting total energy. Follow-up work will test whether similar macronutrient ratios produce measurable benefits in human metabolic trials. A few episodes back, the show covered cellular aging interventions, and today's mouse data adds a dietary route that shifts metabolism without calorie restriction. The low-protein Mediterranean-style diet allowed mice to eat more calories while losing fat and showing less frailty. The benefit appears linked to restricted methionine availability, which shifts metabolism toward fat oxidation. Human cohort data in the same study already associate lower animal protein intake with reduced obesity and diabetes prevalence. Next, controlled human feeding trials will determine whether the same macronutrient balance produces comparable metabolic shifts without compromising nutrient adequacy. What dietary variable would you most want tested in a follow-up human study? Now shifting to a study that corrects a long-standing assumption about animal behavior and human safety. A new study directly measured venom yield and composition across age classes in multiple rattlesnake species. Young snakes delivered controlled amounts comparable to adults, while adult bites injected substantially larger volumes and produced more severe clinical effects. The team traced the more dangerous juveniles claim to repeated inaccuracies in decades of news coverage rather than primary data. The finding corrects a widespread public safety misconception that has influenced first aid guidance. Now, here's something most people get wrong. Most people assume baby rattlesnakes are more dangerous because they cannot control how much venom they inject. In reality, young snakes meter venom with the same precision as adults. Right now, as you consider outdoor safety, the key variable is not age but the absolute volume delivered. Adults routinely inject far larger amounts, producing more severe bites. A memorable figure from the study is that adult bites delivered substantially higher venom loads than juvenile ones across multiple species. The practical takeaway is to treat every rattlesnake encounter with the same caution, regardless of size, and to ignore outdated first aid advice that singles out juveniles. University of Michigan researchers tracked morning glory populations over 9 years under rising temperatures and falling pollinator numbers. Plants shifted investment toward floral traits that attract remaining pollinators. This change cut the rate of climate-related adaptation by 96%. Repeated measures of selection gradients on leaf and flowering traits documented the trade-off. Agricultural weeds and crops may face comparable evolutionary constraints when pollinators decline. The 9-year dataset captured both temperature increases and pollinator losses in the same populations. Selection pressures redirected resources away from thermal adaptation traits. NeuroVFM was trained on standard clinical MRI and CT examinations collected across a health system. The model produces representations that improve diagnostic accuracy, automated report generation, and triage decisions for multiple neurological conditions. Performance gains held across scanner vendors and patient populations not seen during training. The approach demonstrates how existing private imaging archives can be repurposed for safer, more generalizable medical AI. Training drew exclusively from routine hospital scans rather than curated research datasets. The resulting embeddings support tasks spanning several neurological conditions simultaneously. Researchers modified adenosine deaminase acting on RNA to act on DNA while minimizing bystander edits at nearby adenines. The engineered enzymes were tested across multiple genomic loci in cell culture, showing high on-target efficiency with sharply reduced off-target activity. The system expands the base editing toolbox beyond current cytosine and adenine editors. Next steps include delivery optimization for in vivo applications. Tests covered several distinct genomic sites to assess consistency. Off-target reduction occurred without loss of overall editing efficiency. A new formulation pairs cytosine base editors with uracil DNA glycosylase inhibitors delivered via virus-like particles. The combination produced efficient editing in mouse liver and other tissues while limiting indel formation. Glycosylase inhibition prevents excision of the edited base, raising conversion rates without increasing DNA damage. The platform is being evaluated for additional tissue targets. Virus-like particles carried both the editor and the inhibitor components together. Editing outcomes were measured in liver and extrahepatic tissues. The structure of the type IF3 cast transposase, TNSB, bound to left and right transposon ends, shows the distortions required to accommodate sequence asymmetry. Molecular dynamics simulations indicate these distortions enable coordinated assembly of the paired end complex. Mutational analysis confirmed that the resulting protein-protein interface is necessary for efficient transposition. The findings supply design rules for engineering Cas systems to carry larger DNA cargoes. Cryo-EM captured the transposase in its DNA-bound state. Simulations revealed how end asymmetry is accommodated during complex formation. A hybrid quantum classical generative model sampled latent vectors from a photonic quantum processor to seed peptide sequences. Across 131 HLA alleles, quantum priors increased the fraction of predicted strong binders, with largest gains for alleles that had limited training data. In vitro ELISA validation on 3 understudied alleles confirmed that quantum-designed peptides stabilized peptide MHC complexes more effectively than classical baselines. The method offers a route to personalized vaccine and immunotherapy antigens. The photonic processor generated initial sequence distributions. Validation focused on alleles with sparse prior data coverage. A standard proteomics spin tip retains peptides after digestion while allowing genomic DNA to pass into the flow-through. When combined with deep visual proteomics, the approach yields matched genome and proteome profiles from the same cells in archival melanoma samples. The method works on formalin-fixed paraffin-embedded material without specialized equipment. It opens cell-type resolved mutation proteome studies in existing clinical biobanks. DNA flows through while peptides remain captured on the tip. Archival melanoma specimens provided the matched profiles. Advanced interferometric observations revealed organized drift patterns in cold, dense gas concentrations that precede star formation. The measurements resolve velocity fields on scales previously inaccessible, showing how gravity and turbulence interact inside these cores. The data constrain models of the earliest stages of solar-type star formation. Continued monitoring will test whether similar flows appear in cores of different masses. Radio telescope arrays captured the internal motions. Drift patterns emerged at scales smaller than prior observations allowed. Dental wear and isotopic analyses of Homo floresiensis remains indicate a diet heavy on scavenged large animal carcasses. The pattern differs from expectations for active hunting and suggests the species may have occupied a distinct ecological niche on the island. The findings reopen questions about the timing and route of hominin arrival in Southeast Asia. Additional fossils will be needed to confirm whether this foraging strategy persisted across the species range. Wear patterns on teeth aligned with scavenging rather than hunting. Isotopic signatures matched consumption of large animal remains. Brown University chemists synthesized and characterized molecules containing carbon-bismuth triple bonds. Spectroscopic and computational data show that relativistic effects blur the textbook distinction between sigma and pi components. The work provides the first direct experimental evidence that periodic table trends in bonding change qualitatively for the heaviest elements. Similar effects are now being explored in other superheavy element systems. The synthesized compounds featured carbon-bismuth linkages. Relativistic contributions altered expected bond character. University of Ottawa researchers shaped laser light to replicate particle dynamics in complex materials. The optical simulator reproduced transport behavior across hundreds of distinct Hamiltonians without requiring larger electronic circuits. Validation against numerical models confirmed quantitative agreement for both localized and delocalized regimes. The platform offers a compact testbed for materials that are difficult to fabricate or measure directly. Laser beam shaping encoded the target Hamiltonians. Hundreds of different transport scenarios were tested optically. A university at Buffalo team applied quantum optics methods to enhance visibility of a subtle interference pattern generated inside the eye. The amplified signal could serve as a non-invasive indicator of retinal health. Early tests in human volunteers showed the pattern could be recorded with standard ophthalmic hardware once the quantum illumination was applied. Larger clinical studies are planned to correlate signal strength with known retinal diseases. Quantum illumination boosted the otherwise faint interference signal. Volunteer recordings used unmodified clinical instruments after illumination. Laboratory modeling of a synchronously rotating planet showed that interior heat can circulate in a stable loop between the permanent day and night sides. The circulation creates latitude bands where surface temperatures remain within liquid water ranges despite extreme stellar irradiation contrasts. The result expands the set of orbital configurations considered potentially habitable. Future atmospheric observations will test whether such heat redistribution occurs on real exoplanets. Modeling focused on tidally locked rotation states. Heat flow established stable temperate latitude zones. Keep an eye on follow-up human feeding trials that will test the low-protein Mediterranean macronutrient ratios in metabolic studies. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents for Beginners, Artificial Intelligence Explained Simply, for beginners and curious teens. Find every show free at neranetwork.com. And on the website, every episode's visuals live in our free image gallery at neranetwork.com/gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.